Okay, so now we have another advanced mechanics question here. We are asked, during an experiment, a student measures time of flight as 3.52 plus or minus 0.02 seconds. So here we have a time and we have a range of error. We're asked, what is the maximum possible projectile height? Okay, so we have two different times that we care about in this question. We have a time maximum, which is 3.54 seconds, and we have a time minimum, which is 3.50 seconds. Now we know time of flight is equal to minus 2 uy over g. This implies that the initial velocity in y, this implies that the time of flight is equal to the initial velocity in y over 4.9. So we can use these two times of flights to find the two initial velocities, find those two velocities and our acceleration and velocity formulas to find what the heights are. So here we have the time of flight associated with the maximum time. Time of flight is 3.54, and this is equal to uy over 4.9. So this implies that the initial velocity in the first case is 3.54 times 4.9. This is, as a fraction, 8673 over 500. We want these exact. So this is one case. This is the Tmax case. In the Tmin case, we have the time of flight is 3.50, which is equal to u of y over 4.9. This implies the u of y in this case is 3.5 times 4.9. 3.5 times 4.9 is 343 over 20. 3 over 20. Now, so these are the two separate cases we're thinking about. We're thinking about a minimal possible case and a maximal possible case. We now need to find the maximum height. Now we have a formula for finding height. We know that the maximum possible height is the negative of u of y squared over 2 times g. And this is actually the same as u of y squared over 19.6. So we can calculate the two maximum heights here. The maximum height associated with the maximum time is going to be, and our calculator is a little bit pushed to the limit here, right? We're putting very precise values into our calculator in order to try and get very precise values out. The calculator, of course, can't handle this. So the maximum height in this first case is height max 0. So we have to, not 0 point, we have to square, so it's 8673 over 500 squared divided by 19.6. That is 15.35121. So equals 15.35121 dot dot dot. That's meters. Height maximum in the minimum time case, we just need to change the u of y. So the u of y is now 343 over 20 squared over 19.6. This is 15.00625 dot dot dot, and that is in meters. So during the experiment they measure the time. What is the maximum possible projectile height? The maximum possible projectile height is the 15.35121. This occurs with the condition that the time is maximized. Right, so when you have a range, the easiest way to deal with a range is usually to check the two extremes. In this case, the two extremes are going to give us, one is the bigger one and one is the smaller one. You may also choose to check the middle value as well, so it wouldn't be insensible to check 3.52 find the time of flight for that, and then calculate it. Because the formulas we're using for time of flight here are linear, and because we are then squaring those numbers, it's going to work out that this height is in fact the maximum of all possible values in here. You could use differential calculus to do this. We don't have differential calculus at our disposal in an algebra-based physics course. You could do that, but when you have a range, you're usually going to check the extremes. One of the extremes will typically be a maxima, one of them will typically be a minima. It's possible for both of the extremes to be minimas or both of them to be maximas, but usually for an algebra-based physics course, checking those two extremes, whatever the bigger one is the maxima.